Hey everyone, I hope you're doing good. Today we have another Leetcode problem here, which is 169 majority element. So we're given an array of nums, alright? And so I actually have written down all the different information that we need. So in nums, that is the array itself, which is a number array. Okay? Then we're given a size of n, alright? So this is just the size of the array. Alright, and so that is the variable of n, and that can be understood as the amount of items within the array itself. Alright, and this array is the nums variable. Now, in order, what we're doing here, if you haven't realized from the question itself, is we are returning the majority element. Now, to get this majority element, the element must appear more than n divided by 2 times. Alright, and another cool thing about this problem is that you can assume that the majority element is always existing in the array. Okay, so let's get right into it. So to do this, I'm going to actually use a hash map. Alright, and the reason why I'm going to be using a hash map, alright, the reason why I'm going to be using a hash map is to store the occurrences of a item, alright, or a number. Alright, so we're just going to be storing the occurrences, or you can say the count if you want. Really, it's a count. So you're going to be storing the count of an item, or the occurrences of an item, which can be also thought of like an item can be thought of as a number. Okay, cool. And the way that this, like, the reason why I picked this data structure out of all of them, like, is because first of all, it's blazingly fast. Okay, it's really fast. It's constant time, all right, or O of 1. The next reason is the way that it structures data. Okay, and that is through key value pairs. Okay, so it's a key value pair system. Alright, and what do I mean by this is you're going to have a key which is associated with a value. So in our case, we can map every number to their corresponding occurrences, or counts, you can say. So you can see how this specific data structure works super well in our use case. Alright, because we want to store the occurrences of a specific data. Alright. So how are we going to be actually doing this? We're going to be doing this through a for loop, which will be looping or mapping, you can say. Alright, our array. In our case, it's nums. Okay? So, for example, if we looked at example 1, which is 3, 2, 3, it looks something like this. Alright, if we visualize it, because I love visualizing my problems first and then solving them, right? So it looks something like this. We're going to go to this element first. Alright, we're going to perform some logic. So we're going to perform some logic, which will actually branch out from here. Alright, so from here itself. And then we're going to move on to the next number. Perform the same logic again. Then go to the next number and do the same exact thing again and perform the same logic, or you can say algorithm, because it is technically some predefined steps, which is what an algorithm is. Okay, so now branching out from all of this, right, that we learned, let's go and actually design the logic. The logic is very, very simple. All we're going to be doing is, first of all, we're going to be checking if the key, which is the number itself, exists. Okay, if it exists within the algorithm, or sorry, the hash map, I should say. So if it does not exist, okay, so we're branching into conditionals here. So if it does not exist, what we are going to need to do is create the key with one value. Okay, because the reason why we're creating it with one value, by the way, is because the item or the number already exists in our array. And we know that it will have at least one count because we already stumbled across it through this through this mapping, right? Because we're directly accessing the variable of the item, so we know that this number does in fact exist in our array. We just don't know how many times, and that is the job of the next conditional, and that is if it does. Okay, so if the key already exists, all right, I'm actually going to use a different color. It'll really help differentiate. But if it does exist, all right, what we're going to be doing is, instead of creating the key with one value, right, because we can assume that there's going to be at least one count, what we need to do is, now all we need to do is we need to increment based off of our previous value. All right, so in our case, okay, that's just going to be increment by 1, right? Because logically, when you are counting through occurrences, or you want to find out how many times an item exists on a specific data medium, it makes sense to just increment by 1, right? Because that's just the standard way of doing things. So with our logic here, what we're doing is we're first checking if the key exists in our hash map. Then we're doing some conditional logic. This over here is our conditional logic. Okay? And this conditional logic includes two things. Those two things are, if the value does not exist in our hash map, we're going to just create it like the key, which is our number, and we're going to, for the value, which is our occurrence, right? We talked about this over here, right? With the key value pair data structure, we're going to just put it with one value. Now, if it does exist, all we're going to do is just increment the value, right? I should be more specific here, actually. We're going to be incrementing the value, okay? The value by 1. Okay, nice. Okay, so now what we're going to have in the end, so our result, that is the wrong spelling. Our result is going to be a dictionary. That's just the Python way of saying it, or hash map, which is how I like saying it because it's applicable to all languages in computer science. But you're gonna have this hash map or dictionary with a key value pair, and this key value pair will represent your number within the array and its corresponding count. Okay, so how many times is it in the array? Okay, so this is our final result from all of this logic. Now, what do we do with this result? Well, all we're going to do now is we're actually going to implement a new algorithm, okay? And so we're going to implement new logic or algorithm, whatever you want to call it, here. And what we're going to do is we're going to actually loop or map through this hash map too. Now, there are granted different ways that you can do this. I'm using a hash map because I want to actually teach you guys like about hash maps and key value pairs, right, or dictionaries in Python. But there's many different, maybe more intuitive approaches, but this is just a very acceptable one as well. Anyways, you're gonna be mapping or looping through this hash map, okay? And once you loop through this hash map, okay, what you're gonna be doing is within each of the elements of the hash map, so I'm going to say within each element. So in our case, the hash map would look something like this, with the accounting for the array that we have, it'll look something like this. So pretend this is like the hash map, right? It's represented like squiggly lines. So you're gonna have like 3, and it's gonna have a count of 2, and then you're gonna have 2, and it's gonna have a count of 1. I'm actually gonna be moving this like here. Nice. Yeah, so as you can see, this is how the hash map would look like, okay? And what we're going to be doing is we're going to simply be looping through each element. So that would mean going here first and then going to this one next. So we're going to have direct access to this specific element, and then again after this, direct access to this element. Same exact logic that was applied when we did it within here, right? And you guessed it, we're going to perform some logic on this. Okay, so we're going to be performing perform logic based on the data that we get with each element that we iterate over. Okay, and same is going to apply for here. And this logic, we're going to branch out even more. This logic is actually going to be just an if statement. Very, very simple. It's just going to be an if statement. So it's just going to be an if statement, and this if statement is just going to say that if you're over a specific condition, right? So if I actually, I can look in the Leetcode. If I actually look at the Leetcode, it says that if it appears more than this many times, then it's considered the majority element. So that's the condition that we need to fill for this to be considered the majority element within this question, right? Obviously, it does not apply to all questions, but in this question we can use it. And if you look here, if I just scroll up, within the information given, a condition is actually that the element must appear this many times for it to be considered, I should actually add, for it to be considered the majority element. And this is why it was so important for us to store the occurrences of the specific element, because for it to be a majority element, we need to know the amount of times each element appears, right? And we do that through hash map. So everything logically builds up on itself. So here, all we're going to be doing is we're going to say if, all right, and this is actually our arrow, if it wasn't obvious, but if it's greater than, I don't know if, is that greater than? Yeah. If it's greater than n divided by 2. Remember, n is a variable. That's why I decided to reference it at the top. So it's very, very clear upon what it is, right? It is a simple variable, which is the amount of items within the array, nums. This is why I went through it at the very beginning. So, you know, when I say n, there's no confusion. Right, but n is just the number, and you just divide it by 2, right? Very, very simple. And basically, what this does is when we run this statement, so I'll use blue for that. So when we run this statement, what we're doing is we're simply saying if the element is the majority. Okay, it's as simple as that. Is the element the majority? And okay, you might be a little confused right now. How is, you know, seeing if you know, your element count, right? So your element count, which is your value within your key value pair. So basically, seeing if the value is over this formula or function, whatever you want to call it, how is seeing if it's over this numerical value, going to represent, how is it going to represent the majority? How is it going to represent the majority, right? It makes no sense theoretically, like just by first glance, right? Like if I showed someone this, they'd be like, are you crazy? That makes no sense. But looking at our Leetcode, right? looking at our Leetcode problem, you will see that we actually have a condition here, right, which is exclusive to our specific condition, right? So in our case, it's just n divided by 2, and specific to our problem, I should say, not condition. That's my bad. I'm having a brain fart here over here a little bit, but yeah. So okay, sorry about that, guys. I was just thinking here. Okay, so now that we understand how all of our logic works, right? I'm gonna just go through it again, just so that everything is clear. We are using a hash map, which is a data structure, to store the occurrences or the count of an item, all right, which is our number. And the reason why we're doing this is because our condition actually requires us to know the amount of times an element appears, right? Because this value, right, this value here actually represents, right, it represents a count, right? It represents a count or amount of times, right? So since it represents that value, logically, the value that you're comparing has to be similar, right? It has to be the same, right? It has to represent the same data. So that's why it represents the time or the occurrence or the count of a value, right? And we need to obviously store that because there's no other way to reference it, right? And we're going to do that through here. These are the credentials or the resume of a hash map, and it's fast. So, you know, you're going to not have any issues with performance. There's structured data, right? The way that it's structured is key value pairs, which makes sense for our data because we can have a number which is mapped to a key, and the occurrences or the counts which is mapped to the value, right? This is how we're going to go ahead and actually count, right? And then after this, we're actually going to be doing another for loop, and in here we're actually going to be looping through our specific dictionary, right? Okay, so it's a very, very simple algorithm, and let's actually go ahead and code it out now, right? Okay, so we're gonna start off by getting our specific variables that are required, and that are nums and n. Nums is already defined for us, right, within the parameters of our method, but n is actually not, and that's simply the size, as we know, or the items. So we can use just the length function to figure that out, and it is, again, as we saw within here, it is the amount of items within the nums array. So we're gonna, in our methods, we're gonna put nums, so it knows, Python knows that we're talking about the nums array. Now we have to actually define another variable, and this is an optional one. This is just the one that's specific to our problem, and that's just hash map. That's how you define hash map. So within here, actually, I'm going to add a brand new, and this is, I'm gonna say based on our solution plus VR, and it's going to be h, and this is just the hash map. Okay, so this variable is just going to store our hash map. That's obviously important because that is storing the occurrences for our items, right? Okay, cool. So now what we're going to do is we're going to loop through our nums. So for items, all right, sorry, item, so this is actually going to represent each of the values within our array. So for example, if we're using this, it's going to represent 3, then it's going to represent 2, then it's going to represent 3, and it's going to go through the logic within this loop with each and every one of these items, right? So for item in nums, all we're gonna do is we're gonna say if, and we're gonna say if item in h, then all we're gonna say is h item equal plus equal 1. Otherwise, h item equal 1, like that. Okay, so what did I just do here? Well, all I said is if item is within h, and what this syntax means is that if the key item is within our hash map, then we know that the key value pair already exists, so we just need to append it by, or I should say increment it by 1, right? Because we just want to increment the occurrences, and we do that through this syntax, which will update our value, right? Otherwise, okay, in this case, this is the worst case scenario, which is that the value does not exist, and if the key value pair does not exist, right, this pair, then we're going to actually initialize this pair, right, like this, and we're going to give it the value of 1, because again we can assume that there's going to be at least one count because we saw it already once through this iteration of the item. So now we have our counts in our h variable. So what we're going to do is, as I said, we're going to actually have another logic, and in this logic we are going to be just checking this if statement. So we're going to do another for loop, and we're going to be performing the logic of this if statement, and this if statement will tell us if the element is the majority due to the structuring of the question. So it's just going to be for, and again I can use, I'm going to use key and value. There's going to be two variables, right? They represent the key and the value, right? Key value pair, right? Because there's two different values. And then it's just going to be in h, right? So that way we're referencing to our hash map. And all we're going to do within here is we're going to say if our value, right, because that's our count, is greater than, right? This is our greater than symbol. Yep, this is our greater than symbol. And it's going to be n divided by 2, right? Which we can actually specify in a variable, and that variable will be called thresh, or actually I'll call it max underscore amount, and that's just going to be n divided by 2. And again, n is just referencing to this variable here, which is our size, and I'll just use the max underscore amount. This is just for code readability purposes. And if it is this, then we're just going to be returning, because again this is a method, so we can return values, and we're going to be just returning the key, because the key is associated with the number, right? Remember, all of this has been written down here visually for us, right? So the key is our number, and then the values is occurrences, so that's why we use the different values accordingly. If it's not, then just move on to the next key value pair. And if you can't find any, then we're just going to return 0, because we can't find an array. Sorry, a max value. So if I just hit submit now, everything should work. So cannot unpack non-iterable int object. Okay, so we're getting a little bit of an issue. I believe this issue has to do with the way that we initialized it, which maybe results in the value not being an integer. I'm actually not sure. Cannot unpack a non-iterable int value. Line 14, eh? So it's over here. So maybe if I do like integer like this, I'm not sure. I'm just trying. Maybe it might work. Let me see. Okay, maybe we can do something like this. Hold on. maybe instead of doing this, let's actually use this, and this is called default. Hold on, default dict, like this, and it's gonna be int. So this way, all we're saying is that the dictionary is going to be with integer values. All right. Oh, sorry. I've actually made a mistake in our, I believe our, over here, and that's going to be dot items. We have to write dot items like this. All right. So this way, this is just how the syntax works. So this way, we're actually getting the key value pairs. Let me try it now. Perfect. So if I submit this now, everything should work. There you go. Beautiful. So it works.